So guys, we got the float circuit. So you might remember this from lecture. Easy circuit, a little trickier to build on the PLC. And just like all of them, we have to start with what we're going to call our inputs. And we want to make sure we don't run out of inputs, because this has actually got quite a few of them. So if we look, we've got 1, 2, 3, 4, 5, 6, 7, 8. So we'll be able to get this done with our PLC, because our PLC's got 9 inputs. So here we're just going to go across, call that I0, I0.1, I0.2, I0.3, I0.4, I0.5, and we're going to use these overloads here because we have overloads for each motor. So we're going to call this one I0.6, I0.7, and I don't think I missed anything. Looks pretty good. Once again, it's I0.0. Then we have to label the actual outputs that we want to use. So we want motor 1, obviously, so that's going to be Q0.0, Q0.1. We want the buzzer, Q0.2. And we want a warning light, Q0.3. We know this CR is going to be a memory bit. If we're looking around, that's definitely going to happen. We'll use M0. The only thing else that we need is we're going to need our inputs for our 2 motors. So once again, those are typically built like this, all the way over to a memory bit. We already used M0, so this overload for motor 1, and we need an input to drive that. So that's where we're going to use input 6. So we'll go I0.6, and we need one more to another memory bit, which we'll call M2. Overload. Once again, just coincidental that M2 lines up with 2M for our overload. We'll call that I0.7. And that looks pretty good, but now we have to take this whole thing and build it on a blank sheet of paper. And once again, the best way of doing this is just say one line, get that done. This will be open, open, open with a branch rung. We got to put the overload before the coil, so that'll be closed, coil. And once again, when we're doing the overloads, it's best when we're simulating them to make them open contacts, because we're going to be using single pole switches in the on position, and that'll make that true. So we're going to go open, 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 coil. And that's how it's got to look. Open, 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 open. So let's take a look again. Open, 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 coil. That's how that should look. This will be I0.0, I0.1, I0.2. Once again, we've got to remember that this input is tied into a contact that's open. When we look what that is, we made it M1. So this has got to be M1. And then our Q0.0. And that's going to represent motor number 1. And we need a holding circuit under here. And because that's tied into Q0.0, that will be Q0.0 for the holding circuit. So that's just one rung. We got to continue doing that for each one. So how do we go about that next line? We're going to duplicate this, and then we're going to come around to this. That will then meet that criteria. So this is going to be open, 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 coil. It's really exactly the same. The only thing we're going to change is the coil number and the input memory bit contact. So let's do this again. Open, open, open with a branch. For a holding circuit again, open, Q0.1. This will be motor 2, pump motor number 2. This will all be the same. I0.0, I0.1, I0.2. This memory bit, which is this this overload contact, which we're deliberately making an open contact like a stop button, is tied into input 7. We determine input 7 is going to be tied into memory bit number 2. So we'll go memory bit number 2. Q0.1 controls that line, so it's going to control this contact just like it would in a regular relay. And now we've got all that taken care of. Now we got to do this line. Same thing. We got to come off of here, make this line. So we're going to have an open, open, closed, coil. Open, open, closed, coil. That's going to be our buzzer. What do these represent again? That's I0.0, I0.4, I0.0, I0.4, CR. Well, we got to know what CR is tied into. We know that it belongs to MO, so we can take this MO here, MO here. So now this becomes MO, and we have that done. We got to duplicate this line now, except branch down to here. So it's going to be open, open, Q3. Open, open, Q3. Q3 in this case is a warning light. The two opens prior to them, I0.0, input 4. We're getting there, so we've got that done. We've got that done. Now we've got open, 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 memory bit. So it's going to be this whole line right here. Open, open, open with a holding circuit, and M0, which is my reset. I0.0 goes here. I0.4. That brought me here. Now I've got I0.5 going to my MO, which means my holding circuit is MO. Now we've just got to create two inputs for our overloads. So we're going to go open, which is going to be a single pulse switch. And we'll do it again for the next overload. And remember, this is input 6 for motor 1 overload, I0.6, and M1. We're going to call that overload for 1M. And then this will be input 7 which will be tied to M2, which will be overload for 2M. That's pretty much what you need. So take a picture of that whole scenario, and that's how you got to put it in the program. See you at the next video.